Let's start with the thing that makes purring genuinely strange. Cats purr when they're content. They also purr when they're frightened. They purr when they're in pain. They purr during labor. They purr when they're dying. The same sound, produced by the same mechanism, across emotional states that couldn't be more different. If purring were a happiness signal, this would be incoherent. It would be like smiling when terrified. The reason purring appears across such different contexts is that happiness is not what purring is primarily for. Purring is a self-regulatory mechanism. It is the nervous system using a specific vibratory frequency to manage its own state. The emotional context varies. The function doesn't. But before we get into the contexts, it's worth understanding why domestic cats specifically can purr in the way they do, because it's not universal across cat species, and the reason it's unique to small cats tells us something important about what purring evolved to do. Large cats, lions, tigers, leopards cannot purr. Or more precisely, they can produce purr-like sounds during exhalation only, not continuously across both inhalation and exhalation. The anatomical reason is that in large cats, the hyoid bone, the bone at the base of the tongue that supports the larynx, is partially ossified but remains somewhat flexible, which allows the throat structure needed for roaring. In small cats, including domestic cats, the hyoid is fully ossified. This prevents roaring, but enables the specific laryngeal muscle mechanics that produce continuous purring. The evolutionary interpretation is that large cats evolved for an acoustic niche where distance signaling, roaring, was the priority. Small cats, including the ancestors of domestic cats, occupied ecological niches where close-range social communication mattered more. Purring is an intimate signal. It operates at close range. It evolved for the kind of social bonding that happens between individuals who are physically close, mothers and kittens, colony members at rest together, bonded pairs engaged in grooming. This is relevant because it tells you what the signal is designed for. It was built for close physical contact situations. It is a regulatory tool for managing the nervous system during proximity with other individuals. That's why it appears in such different emotional contexts, because the nervous system uses it whenever proximity is involved, whether that proximity is positive or negative. Now the mechanical basis, because it's not what most people assume. Purring is not produced in the lungs or by a particular pattern of breathing. It's produced by the laryngeal muscles, the muscles around the voice box, which contract and release rhythmically at a rate of 25 to 150 times per second. This rapid cycling creates a pressure differential in the airway on both inhalation and exhalation. The sound is generated by the turbulence this pressure differential creates in the airflow. And because the mechanism operates independently of the breath cycle, it can run continuously. The purr doesn't pause between breaths. This matters because most people, when they first learn about the laryngeal muscle mechanism, think of it as a voluntary behavior. The cat is choosing to purr by flexing certain muscles. This is partially true, but the full picture requires understanding the neural oscillator. The purring mechanism is initiated and maintained by a cluster of neurons in the brainstem that fires in a self-sustaining rhythmic pattern. This is what's called a central pattern generator, a neural circuit that produces rhythmic motor output without requiring continuous voluntary control or conscious input. Once the circuit is triggered, it runs on its own. The cat doesn't have to actively maintain each individual laryngeal muscle contraction. The oscillator handles the timing autonomously. What this means practically is that purring can run as a background process in parallel with other activity, including sleep, nursing, grooming, or being handled at a veterinary clinic. The cat doesn't need to consciously attend to the purring to sustain it. The nervous system triggered the oscillator, and it runs until the conditions that triggered it change. This is also why cats sometimes purr when they appear to be completely unconscious. Or nearly so. The oscillator doesn't require wakefulness to operate. Now, the four contexts and why each one makes sense given this mechanism. Contentment purring. When your cat is relaxed and being petted in a safe location, the nervous system is in a low activation state, and the purring mechanism runs as both an expression and a reinforcement of that state. The vibration at these frequencies appears to stimulate serotonin release and reinforce parasympathetic nervous system activation, the rest and digest state. The cat is not just expressing happiness. They are using the vibratory mechanism to deepen and sustain the positive state. Self-soothing purring. When your cat is stressed, frightened, or in pain, the nervous system activates the purring mechanism as a coping tool. The same vibratory mechanism that reinforces positive states can modulate negative ones. This is the context most people find surprising. A cat purring at the vet while clearly tense, purring while hiding, purring when injured or ill. The purr in these cases is not a signal that everything is fine. It is the nervous system deploying the best regulatory tool it has to manage a difficult state. Birth and death purring. Both labor and dying involve extreme physiological states that generate intense nervous system activity. The purring mechanism activates as a regulatory response to that intensity, running the same process it runs in any high activation state. Queens purr throughout labor. Cats in their final hours often purr. In both cases, the mechanism is not communicating the state. It is managing it. Solicitation purring. In 2009, researchers at the University of Sussex published a study on a specific variant of purring they called the solicitation purr. Karen McComb and her team recorded cat purrs in two conditions: baseline purring and purring during active food solicitation behavior. The recordings were then played to human listeners, including people who had never owned cats. The result, human listeners consistently rated the solicitation purr as more urgent and less pleasant than baseline purring, even when they couldn't identify what was different about it. Acoustic analysis found that solicitation purring contains an embedded higher frequency component in the 300 to 600 Hz range that is not present in baseline purring. This frequency range overlaps with the acoustic range of infant crying in humans and other mammals. The hypothesis is that cats have learned, through thousands of years of cohabitation with humans, to embed a signal in their purring that activates the same auditory response in humans that infant cries do, a response associated with urgency and the motivation to respond. This is not a conscious strategy. It is an evolved behavioral adaptation. Cats who produced solicitation purrs got fed faster. That trait propagated. Your cat may not know they're doing it, but they are doing it, and your nervous system responds to it in ways you don't consciously register. Now, the bone healing research. This is the section most cat content never covers, and the research is genuinely remarkable. The frequency range of domestic cat purring, 25 to 50 Hz on the lower end, falls within a range that has been studied for its effects on bone tissue. Multiple studies have found that cyclic mechanical stimulation at these frequencies promotes bone remodeling, increases bone mineral density, and accelerates healing in fractured bone tissue. The research was originally developed in the context of preventing bone density loss in astronauts during extended low-gravity missions, where the absence of normal mechanical loading accelerates bone resorption. The implication for cats is a hypothesis rather than established fact, but it's taken seriously in veterinary literature. Cats spend a large proportion of their lives at rest. Prolonged inactivity in other mammals leads to significant bone density loss. Cats, comparatively, maintain excellent skeletal density and show extraordinary resistance to musculoskeletal injury. The famous writing reflex aside, cats fall from considerable heights and sustain injuries far less severe than anatomy alone would predict for their mass and velocity. If the purring mechanism functions in part as a self-administered vibratory stimulus to skeletal tissue during rest, it would explain both the maintenance of bone density despite extended inactivity and the superior healing rates observed in cats following fractures compared to other mammals of similar size. This is not proven, but it is a serious hypothesis supported by the frequency data, and it changes the way you think about what purring is. Not a sound a happy cat makes, a multi-purpose biological tool with regulatory, social, and possibly structural functions. How do you tell which context you're in? Context and body posture are more reliable than sound. A cat purring with relaxed muscle tone, loose posture, eyes soft or half-closed, in a familiar, safe location is almost certainly in a positive state. A cat purring while crouched with tense musculature, slightly reduced eye aperture, ears at or behind neutral in an unfamiliar or stressful situation, is almost certainly in a negative state. The solicitation purr tends to emerge specifically around feeding time or when the cat wants access to a resource or your attention. It may sound subtly different once you know what to listen for, slightly higher pitched, slightly less steady in rhythm. Here's what this video is actually about. Purring is not a signal. It is a mechanism, a self-regulatory biological tool with evolutionary origins in close-range social bonding, a neural substrate that operates semi-autonomously, and functions that span contentment, stress management, possible bone maintenance, and social manipulation through embedded acoustic urgency signals. When your cat purrs at you, reading it requires the same thing. Reading all feline signals requires this week, looking past the sound to the whole animal. The posture, the eye state, the location, the context. These tell you what the mechanism is doing. The purr tells you the mechanism is running. Tomorrow we look at 7 concrete actions you can take that tell your cat's nervous system you are safe. Not gestures of affection, specific behavioral inputs with specific neurological effects, each of which produces a measurable change in how your cat's threat model registers you.